Hey, it's Nick Marshall here. Today I'm going to build an ESXi server and then bootstrap vSAN using a single host local disks. If you're following along in my home lab rebuild series, we're building the first ESXi host in the bunch there, and then we'll move on to the others. So why ESXi 6? Well, we want virtual machine hosting, obviously. We want to use the local storage, and vSAN is a perfect candidate for that. We want a nice stable hypervisor and nested ESXi VMs on top. So first off, what we're going to do is we're going to wipe those local disks. We'll then install ESXi 6, set a root password, and then set the management network up. Once it's on the network, we'll install the vSphere desktop client, configure NTP and SSH. Then finally, we'll configure vSAN to use the local disks. So let's get on to it. First, we're going to mount the G-parted ISO, which will give us the ability to wipe the local disks of anything that's existing, any of the partition information. This is kind of required because vSAN is expecting local disks when you configure it. So let's plug in that ISO and we'll boot up the server using this. Once this is booted, we'll go in and we'll check the existing partition information of each disk that is in this server. I've got a few disks in this server, so we'll go through each one and just verify any existing partition information. So now that that's booted, nearly booted. Let's just go through these. Now it's booted. Okay. So what we're going to do is we're going to select each disk by going into the G-parted utility, which is this one here. Once the screen refreshes, it's going to scan the devices automatically. As you can see, this is unallocated. So I've got a 2 terabyte disk there. It's unallocated in the file system. That's what we want to see. And likewise for each of the subsequent disks in this system, they're all unallocated. So that's good. We could delete the existing partitions if we needed to, but in this case we don't need to because there's no information there. We've wiped them previously. So let's insert the vSphere 6 ISO, the ESXi 6 ISO. And once that's inserted, we'll reboot the server and we'll do an install of ESXi 6. So we'll plug that in. We'll do a power reset on this server and we'll fire up the ESXi installer. As you can imagine, I've accelerated or reduced the time to do a lot of these boot operations. I think the post operations on this server at least takes about 60 seconds. So rather than talk through that or have empty space, I've sped this up just so it's not too boring. So we've accepted the EULA and it's now scanning for available devices. As you can see in here, there's quite a number of disks, a couple of SSDs, a USB device, and some remote disks as well. It's interesting that some of those are remote and some of them are local. That depends on which controllers it's on. We'll set the root password in here, and then we'll go through and do that install. So with ESXi 6, we can actually change whether things are local or remote through the vSphere web client now, which is good because before it was painful having to do it through the CLI. So we'll now reboot this host and we'll unplug the CD first. We'll reboot the host and then we'll get into getting this ESXi host on the network. As that boots up, we'll go in, we'll log in, and we will set the management network to whichever VLAN you'd want. If you wanted it on a VLAN, in this case we want to change the NIC and give it an IP address, so a static IP address. You can find out If you wanted to set yours up exactly the same as mine, all the information's on labguides.com. In this case, we'll do it 192.168.0.111 with a gateway of .1 and a DNS server of .3. We'll give it a host name and a DNS suffix, and then we'll restart the management network. So now that that's restarted, we should be able to install the new vSphere 6 desktop client or C# client. It really depends on what you want to call it. So what this is doing is saying, yeah, I've got the 5.5 version, but I need the 6.0 version to be able to run. So we'll just quickly install the ESXi 6 client. We'll run through that as we get through the security warnings. We don't need the KVM remote desktop anymore. So we'll just run through, I'll just tidy those up. We'll run through this installer quickly. And then once we've logged into the host, what we want to do is we want to enable the remote CLI capabilities. So that client's installed. We'll now log into our host successfully. If I can type the username and password. And then we're logged in. Okay, so first of all, what we're going to do is we're going to set up we'll just check the health, make sure everything's fine, which it is. And then what we'll do is we'll move on and we'll say, okay, this host is no storage. It's on the network. It's not doing anything. We need a data store. But what we need to do is we need to set up a few things first. First, we'll set NTP. At this stage, because this is the first device on our network, we need to specify an external NTP server. We'll build an internal NTP repository or proxy in another video. So we'll just use 0.pool.mtp.org for now. And then what we're going to do is we're going to start that service. Seems to be taking a few seconds. We'll enable SSH now so that we can get into it remotely. As you can see, everything else is set up. DNS is set. The gateway set as we did before, and now we'll go in and we'll enable SSH. So we're going to the security profile and we'll find the SSH service, which it's currently set to stopped. So we'll go in there and we will start the SSH service manually. And now we can open our SSH client, in this case PuTTY, to SSH into this server so that we can set up vSAN because we need storage. So let's set up a single host vSAN. I got this information off virtuallyghetto.com. William Lamb has a great article on there. It's linked on the blog. What we want to do is we want to run ESXi vSAN, and what we want to do is we want to change the default policy to force it to provision even if it can't meet the requirements. So that's the host failure to tolerate setting. We want to force the provisioning regardless of what it is. In this case, we're using vSAN just to be able to use the local disks a little more efficiently. This is not supported. You can't run a production environment like this, but it does give us the ability to have read and write caching on our lab hosts using an SSD. If you were just to set up a data store on a local disk and then try and use, let's say, vSphere read cache, flash read cache, well, then you have to do it per VM and it's a pain in the butt. Whereas this way, it's we're setting the policy so that vSAN will work. What we're not doing is we're not going to use vSAN with multiple hosts, so it's not going to replicate data across the network in this case. So it's strictly a lab use case here, if I can type correctly. So we want to force the provisioning based on all of these priority classes. And once that's configured, and I don't fat finger it like I did that time, but that's okay because we can go in there and fix that. Okay, so now, once that's fixed, default policy, all of a sudden, they're forced provisioning on the cluster level. So now we can change all of the other classes. So we did cluster, now we'll do vdisk, which it's done, and now the VM namespace policy as well. So we'll force the provisioning of that, which means it's going to ignore whether it can or can't meet the policy requirements. As you can say, let's get that. That's the default policy, so that's what vSAN will do. So there's the policy done. Now what we can do is we can actually go in and we can say, I want these devices here, as you can see here, I want these devices to be part of a vSAN disk group. So we've gone in, and as you can see, we've got a couple of SSDs, a number of spinning magnetic disks. I'm going to set up one disk group now, potentially another disk group later, and we will then use that to build our initial Active Directory and other basic services before we start adding external storage into this environment. So what I'm doing is I'm just getting the IDs of the disks that we need to be able to copy and paste that into the command that we need to run. If you right click, you can get the identifier within that list, and then you can always right click and then copy the identifier to the clipboard. So that's handy when you're trying to copy and paste between sessions on both the UI and the CLI. So there's our disks there. It's just an expanded view of what you can see in the UI. Some of them are local, some of them SSD. What we'll do now is we'll go through and we will try and allocate these disks to a new vSAN cluster. So how do you do that? Well, we first of all need to enable a cluster. So to do that, previously in 5.5, you needed to generate a UUID, and then with that command, the UUID could be used to build that vSAN cluster. So to build that UUID, you'd run a Python command, which is in here, to grab a UUID, and then the output of that command you could use as the input on the create vSAN cluster command. But I'll just give you that as an example. So there's the UUID. You can copy and paste that UUID. Make sure that works. And then we just do ESXi vSAN cluster join, and then the UUID, which we've just generated. And then once that's created, takes a couple of seconds. What we can do is we can go into the UI and actually see that, yeah, this has been created. So, yep, sure it is. Sure enough, there's a vSAN data store. It hasn't got any capacity at the moment because there's no disks allocated to that vSAN. But what we can do now is let's just leave this cluster because we want to create it not having to generate our own UUID. Not that it makes any difference, but just to show you the command that you use if you've got 6. Whoops, we don't need to specify the UUID when you're leaving a cluster. You can just leave it. So that cluster is left. And now what we can do, you can see in the background, the vSAN data store's gone. Now we can just say new. We don't need the UUID command anymore. And once the cluster has been created, then what we can do, which it has done just there, then we can go ahead and allocate the disks that we've got to this cluster. So there's our vSAN cluster, for lack of a better word. Now what we need to do is we need to add some storage. So -S is for SSD. We need to go back in here, grab the identifier for the SSD we want to use, which is this. What I'm pointing out there is there's some partitions there. So when I was doing this, I didn't realize, but the disks that I thought were wiped weren't actually wiped. So as you can see on here, there's some partitions there. That's the USB device, that's ESXi. But on this device, see the XXX data stores there? When I try and run this command, adding the storage to the vSAN cluster, it doesn't work. So what I have to do is I have to log back in and actually have to wipe the disks again. Well, properly, I should say. So let's just fire up the gpart d ISO again, which I'll quickly do now. We'll wipe the disk proper, and then we'll go back and rerun that command. So let's quickly accelerate this. And as you can see now that this is loaded up, it's unallocated. What I didn't realize at the time is that a partition table is required. So we need to create the partition table. MS-DOS is fine. We could choose anything we like, but MS-DOS is fine. And then it's just going to create a blank partition table. And I'm going to do this for all the disks. Configure partition table. And that's it. That's all I have to do. I don't have to create partitions, just configure the partition table. Then I can reboot the server. Just power reset it now. And now I'll be able to go in and actually add those those disks to that host. So let's boot this up quickly. And then we will rerun those vSAN commands that weren't running before. So as you can see, that's blank now. Those partitions aren't there. So now what I can do is I can go just sort this so that I can see them a little easier, and go back into PuTTY, re-establish my SSH connection, and I can set that single host vSAN up again. So the vSAN cluster is there, but I still need to add the disks. So let's go storage, add -S for the SSD. We'll get the SSD's identifier, which is this one here. And then what we'll do is we'll go in and we'll add, in my case, it's just a SATA base 2 terabyte disk, the magnetic spinning disk, which is there. We'll copy that identifier as well. And once we've done that, we press return, and it will now actually allocate those disks to the vSAN cluster. So that's done. So let's flick back over to the, well, let's just have a look at it from the UI first. Let's have a look at the list. If I don't typo. And as you can see, the storage is in there as we'd expect from that vSAN cluster. Those two disks are allocated. What we need to do is let's flick across the UI, and we'll actually see that that data store that was created before, just vSAN data store, now actually has 1.8 terabytes of capacity. So thanks for watching, and you'll be able to get some resources there and follow along if you want to continue building out this lab. If you've got any questions, let us know.